Alright, so we're going to wrap up Chapter 8 with Taylor and Maclaurin's series. And we've already handled this a little bit, introduced it. You can see we did, we did this in 8.7 as example 6. And we did this one as example 5. And this we want to memorize. Go back and look at that. And you want to memorize what is the Maclaurin polynomial, or the Maclaurin series, for e to the x. So the difference is that the polynomial has a finite number of terms it stops, and the series is going to continue on. So we're just going to get right into it and continue with what we were doing in 8.7 basically. So turning to the next, because those first two are already done in 8.7, we're just going to move right on to example 3 and continue on with that. So we're going to want to memorize this one as well once we get it started there. So the function itself is just the sine of x, and then we're going to take the derivative of that. So that's pretty basic, and then the derivative of that. So that's going here, and then the derivative of that. And then we're going to look for a pattern. So the derivative of sine is cosine, but it's negative, so. And then the Maclaurin series is when the center is at 0. So we're going to be evaluating these at 0. So f of 0. So the sine of 0 is 0. And then the cosine of 0 is 1. And then the second derivative evaluated at 0 is 0. And then the third derivative at 0 is negative 1. So if we go to the polynomial, remember that sine, so the constant would be 0, and then the next term would be x, and then the next term would be 0, and then we're going to alternate, so then it would be x cubed over 3 factorial, and then it's going to alternate, and it's the odd powers. So really you just memorize what we were just plugging into the formula, and it's alternating like that. So that's coming from this. So f of c, f the center, 0, so f of 0 was 0, so there was nothing there. Then the first derivative was 1, and it was x minus 0, so 1 times x. And then hopefully you realize alternating, those are going to be zeros. And then here the signs are going to alternate. And that's basically it for that. So, but now we need to turn that polynomial into a series. So we're going to say n equals 0 to infinity, and we have negative 1 to the n. So when that's 0, that's going to be positive 1, and when that's 1, it's going to be negative, and so that's going to alternate the signs there. Now x, that's going to be 2n plus 1, so we're going to plug in 0 there, so the first time it's going to be x, and then we plug a 1 in there, we're going to get 3, and we plug a 2 in there, we're going to get 5, so that's going to give us those, and then we want this factorial to match that exponent, so that hopefully is somewhat clear there. So that's the series, and that's what we want to memorize, because that'll help us on the AP test. Okay, so now we'll try to do that for cosine. So we want to have sine memorized. So sine is this. You also want to have e to the x memorized. We did that in the other notes, 8.7. Okay, so it's almost the same thing here. So we start off with cosine, and we take the derivative, and we get negative sine, and then we take the derivative of that, and we get negative cosine, and we could keep going, but we're just trying to do enough to get a pattern here. So that's going to be positive sine. So f of 0 is 1. F prime of 0 is actually 0. F double prime of 0 is negative 1, just plugging into over here. And triple prime is 0. So now, for that first term, You can go back to the front page of the notes if you need to. That's going to be 1. And then we're going to get 0 for x, and then we're going to get negative for x squared. So x squared, and that's going to be over 2 factorial. And then we're going to get the even powers there, and they're going to alternate signs. So it's not that big of a deal if you just memorize what's going on here. So cosine starts at 1, and that actually should be easy to remember because the graph of cosine starts at 0, 1. It starts at 1. And the graph of sine starts at 0. So if you think about it, the constant there is 0. So it kind of matches that idea. Okay, so now we'll get the sigma notation there, and we still need to alternate signs, but we want that first one to be positive, so that's going to be n. And now here, the first exponent we want to be 0, and then we want it to be even, so that's actually going to be 2n. So we plug 0 in there, x to the 0 is 1, and then plug in a 1 and we get x squared, etc. And then here, the exponent matches the factorial also. So that is going to be n 2n, same as the exponent, factorial. Okay, so that's so we want to memorize these for this, or I mean you can just memorize that. Probably is what it would be even better. But okay, so now let's go down here. Alright, so we can manipulate Taylor and Maclaurin series to find other series by doing any of these things that we want to. Okay, so if we want to find the first 4 non-zero terms of sine times cosine, what we can do is take sine, so hopefully we have that memorized. So sine is starts at 0, and then the first term would be x, and then we're going to alternate, so that's going to be minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. So we want to memorize those like we talked about. Okay, now down here we could put cosine. So cosine, remember, starts at 1, and then that's going to also alternate, so that's going to be x squared over 2 factorial, but that's just 2, and then it'll be x to the 4th over 4 factorial, and I'm running out of room down here, minus x to the 6th over 6 factorial. It's a little awkward there. Okay, so if we come back up here, and if we take 1 times all of these things, so we're just distributing here. I'm going to multiply 1 times these, and I'm going to multiply this times those and see what we get. So 1 factorial is just going to be this. Alright, now if we move here and we multiply this times this, that's going to be negative x cubed over 2. So I'm going to put that, I'm going to line it up with the similar power there so that I can kind of put these to organize them. So that times that's that. This times this is x to the 5th. Okay. X to the 5th. This times this, negative times negative is going to be positive. And then 3 factorial is 3 times 2, which is 6 times 2 is 12. So I'm going to write that as 12. And then this next one, that's x to the 7th. It's going to be negative. And that's going to be 5 times 4 is 20, times 6 120, times 2 is 240. Now, I could multiply this by this, but I only want the first 4 terms, so that doesn't really matter. We don't need that term, because that'll be part of the 5th term, and it just said find the first 4. Okay, so moving on to the next one down here. This is going to be x to the 5th over 4 factorial, and then moving here, that's going to be x minus x to the 7th over 6 times 24, so that's going to be 144. Okay, and then like I said, there would be 2 more terms after that, but that's going to be outside of what we had to do. Alright, and then finally down here, this times this is going to be negative x to the 7th over 6 factorial. Okay, so now we want to put those together for our final answer. So let's go, first term is going to be x. Second term, we need to add these 2 together. So that's going to be over 6 plus over 2, because well, there's 2, so that's going to be negative. And we're going to have x cubed. Okay. And so we've got, basically you got 1/6 plus, or 1/3 plus 1/2. So hopefully you see what I'm, oh, that's 1/6 actually, plus 1/2, just focusing on the fractions and the same sign. So that's going to be 3 over 3, so that'd be, multiply by 3, multiply by 3, so that'd be 3 over 6, that'd be 4 over 6, which is 2/3. So that's going to be 2/3. Okay, and then we're going to go to this next one, that's going to be x to the 5th. I'm going to use a different color for that. So that's going to be, interesting, 520 times 6, 120. So that's going to be 1 over 120. And this is plus 1 over 12. And this is 1 over 24. So it looks like we're looking at 120 as our common denominator. So that'll be 10 over 120, and this will be 5 over 120. In the common denominator, so that's going to be 16 over 120, which is 8. I guess I could have divided by 4, that would have been better. 4 over 30, which is 2 over 15. Okay. And then our last one, it's going to be minus, it's going to be x to the 7th, and that's going to be, oh, well, that's not bad at all, because that's just 6 factorial. So, wait a second. No, it isn't. I have to add all these up. Sorry, I was all excited for a second. So, just that. Okay, so 7 factorial. 7 factorial is 720 times 7, that's going to be 5040 as the common denominator. And the first one is a 1 there. And so if we take 5040 divided by 240 to find out how many times, what do we have to multiply this by to get that? So if we divide, that'll tell us what that number is. So that's going to be 21. And I'm just doing positive because I already have the negative sign right there. And then again, 5040 divided by 144, that's going to be 35. And then 5040 divided by 6 factorial is going to be 7. That's how we got 7 times 720. Okay, so if we add that up, we get, what, 50, 56, 57, 64, which reduces to 4 and 315. So that was just the arithmetic part. Hopefully that didn't throw you off, just adding those two together. So to get that, we took the series of sine and the series of cosine and we multiplied them together. Okay. So now let's try it with the first four terms of e squared. So if we think about it, so e to the x, that's another one we want to memorize. So that's 1 plus, and it's all positive and it's all the terms. So it's kind of a combination of sine and cosine, sort of. Not exactly, but kind of like we combined sine and cosine but made them all positive, I guess. We could. So that's going to be x squared over 2 and x cubed over 3 factorial. Okay, so that is x to the n over n factorial. So what we can do here is we can substitute in 2x. So we can either do it here if you can see it, or we can start over here and go backwards. So what we have over here instead is 2x to the n over n factorial. So you could use this, if you substitute there, and then go back and generate your list. So if you plug in 0, that's going to be 1 over 1, which is 1. Now if you plug in 1, you're going to get 2x over 1, so that's going to be 2x. And you can kind of see what happened there a little bit. And then here, if you plug in 2, it's going to be 2x squared over 2 factorial, whatever. And then this is going to be 2x cubed over 3 factorial. So that's going to be 1 plus 2x. This is going to be 4x squared. 4 over 2 is 2, so that's going to be 2x squared. And then here, this is going to be 8x cubed over 6. So that's going to reduce to 4x cubed over 3. So you can see there are kind of two ways we could go about that. We could plug in the 2x on this side, just straight into there, or we could start with the sigma notation and plug the 2x in for that, and then go back by plugging in 0, 1, 2, 3 to get those. Alright, so now we got to try and do something with sine squared now. We could do, probably we could do sine here and sine here, just like we did with sine and cosine on the previous page, and multiply all that stuff out. That would be one way to do it. But hopefully you think, well, maybe you can remember there's an identity that has something to do with sine squared, or maybe not. But so if you think about the cosine of a plus b, that's equal to the cosine of a cosine of b minus the opposite of that, and then sine of a sine of b. But if those were both x, if that was the cosine of 2x, x plus x, which would be 2x, then this would actually be cosine squared x, and this would be sine squared x. So we're trying to get sine squared, so let's switch this to sine squared. So hopefully you remember sine squared plus cosine squared equals 1. So if I want to know what cosine squared is, it's 1 minus sine squared. You could write that out in more detail if you needed to. So this takes us to the cosine of 2x is 1 minus 2 sine squared x. So if we're solving for sine, probably I would add this over here and get 2 sine squared x, and I'd have 1 minus cosine 2x, and then divide both sides by 2. So that's where I'm going to go with this. So if I take this and think about what that would be, so that's going to be 1 minus cosine. So first thing we did was switch sine squared to this, because now I'm going to be substituting instead of multiplying. So I'm thinking that that might be a little bit better for us. So first of all, I'm going to start with this. That's 1. And then minus, and I'm going to put this in parentheses. and now I'm going to expand this. So cosine, if you remember, starts with 1, so that's going to be 1, and then the signs alternate and the exponent, and then we skip. So we skip x and go to x squared. So this is going to be 2x squared over 2 factorial. And then we switch to plus, and that's going to be 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial. Now at first you might be like, hey, that's 4 terms. But you're going to need to look over here and realize that we're going to get 1 minus 1 is going to be 0, and that would just leave us with 3 terms. So we're going to need, because of this, we're going to need one more here. Okay. So hopefully that's showing why there. And then all of that, so this in parentheses was the cosine 2x, and then we have this 2 here also. Okay, so back to what I was kind of saying here, this is going to cancel out. Now if we take a look at what we have left, this is going to be the opposite, so that's going to be positive, and this is going to be 4x squared over 2 factorial divided by 2. So 4x squared divided by 2, that's going to be 2x squared, and then 2 factorial. And I could reduce that just to x squared right now, but I'm going to leave it because I'm going to try and see if there's a pattern, because I want to find the series. So I don't want to simplify these things too much, because then I might not see the pattern that exists in the numbers. Okay, so if we go to the next term here, that's going to be negative, and we've got this. So let's think about it. It's going to be 2 to the 4th divided by 2, so that's going to be 2 cubed, and then x to the 4th over 4 factorial. Sine, and 2 to the 6th divided by 2 is 2 to the 5th, so that's going to be 2 to the 5th. X to the 6th over 6 factorial, and then the 4th term will be 2 to the 7th, x to the 8th over 8 factorial. Alright, so it says find the series and the first 4 terms. So I'm going to that's the first 4 terms. Maybe we could do some cancel stuff, but like I said, we also want the series, so we don't want to cancel too much because we might lose sight of the pattern. Okay, so first of all, we are alternating between positive and negative. We want the first term to be positive, so just n will do that for us. Plug in 0, negative 1 to the 0 power is positive 1, and that's positive, so that works out okay for us. Now, what is next? So there's a 2 in all of these, so we're going to have 2, and we think what power, what can we put for the power? So if we're plugging in 0, we want a 2, we want 1 2, but then we're going to want 3 2s. We're going to want those 2s to increase, so what we can do is 2n plus 1. And if you think about that, if you plug in 0, you're going to get 2 to the 1st, which is 2, and if you plug in 1, you're going to get 2 cubed, and if you plug in 2, you can get, so that's going to work out pretty well. And then x, if you think about it, the powers of x are all 1 more than this power. So we want this exponent to be 1 more than this one, so that's going to be 2n plus 2 for that. And then down here, if you think about this, how does that compare to that? Well, it's the same as this exponent right here. If you notice that, 6, 6, 8, 8, 4, 4. So we want it to be the same as that number, so we can use 2n plus 2 for that. Alright. Some of these are getting pretty, a little bit intense and a little bit of stuff here, but I don't think that it'll be. I'm not as familiar. Obviously, the BC I haven't done as much, so I'm thinking if you have the basic ones memorized, you should be in pretty good shape. Okay, so now we're going to try and see what happens here. So now we're going to do the first 4 terms of this. So if we start off with, hopefully we have e to the x memorized. So let's start with e to the x. Let's forget about the 1/2 right now. We can do that later. Let's focus on these two. So let's actually start here. So that was everything and all positive, if you remember. So that's going to be x and x squared over 2 factorial and x cubed over 3 factorial. Now, let's just stop there for a second and assume that that would be 4 terms. So, okay. So then we also want to add, so I'm just going to put this one right underneath there. We can add them, e to the negative x. So using substitution, that first term would still be 1, but now plugging in a negative x in place of x, or the opposite of x, we would get that. So, and if we move to the next term, plugging in the opposite of x inside here, well, that is actually just going to be the same because we're squaring it, so that's going to be fine. And then here we plug that in, that's going to be the opposite. So now we should realize that we have a little bit of a problem because these are going to cancel and these are going to cancel, and that would just give us 2 terms, and we're supposed to have 4 terms. So we're going to need to keep going here. And this is going to be x to the 4th over 4 factorial. And this is going to be x to the 4th over 4 factorial. And I'm just going to save myself some writing and realize that x to the 5th will cancel out. Plus dot 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 plus. Actually, we're not doing dot 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 because I'm going to skip to the next one. So that's going to be x to the 6th over 6 factorial. And this is going to be x to the 6th over 6 factorial. The 5th power canceled out. Maybe I should have written it. Hopefully it's not that big of a deal. So now, if we take those together and we add e to the x plus e to the negative x, make sure those e's are there. So if I add that together, that's going to be 2. And then I'm going to have 2 of these, so 2x squared over, I already have a common denominator, so 2 factorial, and then plus 2x to the 4th over 4 factorial, and then 2x to the 6th over 6 factorial. Now, if we go back, remember we were actually supposed to divide that whole thing by 2. We're supposed to divide that whole thing by 2. So if we go back and do that, then that's actually going to be, throwing these pens around, 2 divided by 2 is 1, and then this 2 will factor that, cancel with that 2, 2 over 2 is 1. So then we're just going to have x squared over 2 factorial, and x to the 4th over 4 factorial, and x to the 6th over 6 factorial. So that's pretty nice. And if we do the series on that, so that's going to be n equals 0 to infinity. And if we look here, we just want to have x to the 2n power. If we plug in 0, we get x to the 0, which is 1 for the first term. And then we can see that these factorials match the exponent. So we're going to want the same thing for that, so 2n factorial. Whew. All right. So these BC problems can be, well, I don't know, maybe in general a little bit longer sometimes than the AB, but okay. So we got 2 left here. So let's take a look at these last 2. Alright, so there's kind of 2 things going on here. Let's start with this. So we're going to add these 2 together. So if we start with the e to the x, since that has every term, and we could go, and they're all positive, so we go like this, and let's add 6 terms, 1, 2, 3, 4, 5. However, you might want to think about it, cosine is going to have some negative terms in it, so we're probably going to have to go a little bit farther than that. but let's see. So if we do cosine here, this is why it's good to have them memorized, because you can just go straight into them. And remember, cosine starts at 1, just like the graph of cosine starts at 0, 1. And then it alternates, and it alternates signs also. So that's going to be x squared over 2 factorial, and then it skips, and then it's plus, and that's 4 factorial. So that just eliminated one of our terms. So we're going to have to go further. So 1, 2, 3, 4, 5. We're going to need another one. But hopefully you realize that that next cosine term is going to be negative. It's going to cancel that out. So we're going to need another one there. So now if I come back down here, this is going to be negative x to the 6th over 6 factorial. So that's going to cancel out there. So now if we add those two together and see what we get, we're going to have 2 and then x and then x cubed over 3 factorial. And then here we're going to have 2 of these. So we're going to have 2x to the 4th, 4 factorial, and then x to the 5th over 5, and then x to the 7th over 7. 1, 2, 3, 4, 5, 6 terms. So there is our 6 non-zero terms of the series. And then it says approximate the derivative of the function at 0.5. So what we're going to do is take that and calculate the derivative of that. And then, so the derivative of 2 is 0. Derivative of x is 1. The derivative of this, if we bring the 3 down, that's going to be x squared, and the 3 will cancel out that 3, would leave us with 2 factorial, which I'm just going to put a 2 for that. And the 4, if we bring the 4 down, the 4 will cancel out the 4 here, and then this will just be 3 times 2, so the 2's will cancel. So that's going to be x to the, this should have been, okay, hold on a second. So this one was right here, so when we brought the 4 down, I needed to subtract 1 off that, so that's going to be x cubed right there. So x cubed, 4 cancels, 3 times 2, the 2's cancel, so that's over 3. And then we move to the next one, and that's going to be x to the 4th. 5 cancels out that. We're going to have 4 factorial, 4 times 3 times 2. And then the last one down there, that's going to be x to the 6th. 7's cancel out, so we have 6 factorial, which is 720. Then, if we plug in 0.5, and we plug it in for all of these, we can do that on the calculator. It's a little bit annoying, but we would get 1.1. Remember, we want to round off to this thousands place, so that would be that. Okay. Alright, so this last one, there's a couple things that we need to look at. 6th degree means x to the 6th power, in this case, because it's x. And then what is the maximum error of the approximation? So that involves the maximum error is the first unused term. So we need to keep that in mind as we're generating our list. So for the sine of x, remember sine starts with x, and then it's going to go x cubed over 3 factorial. Now if you think about it, we're going to go to the sine, we're going to be substituting in x squared here. So you notice I kind of paused right there. So if we're sticking in x squared, then this is going to become x squared. And we stick in x squared here, that's going to become x to the 6th. So if they didn't have the maximum error, I'm at the 6th degree polynomial right now. but we need to go one term beyond that because the question asks about the error, and that next term after is what's going to give us the error. So if we plug in squared there, that's going to be x to the 10th over 5 factorial. Okay, so now if we take the integral from 0 to 1, this we would have that, and then if we integrate that, that's going to be 1/3 x cubed, and then minus, add 1 to the exponent, so that would be 7, and then divide by the new exponent, so that would be 1 over 7. So that would be 7 times 6, which would be 42. So that is where we would be focused. Now we're also going to have this last term here, which we need for the error. So that's going to be x to the 11th, and that's going to be divided by the new exponent, so that's 1 over 11. So 11 times 120. So that's going to be 1320. Okay. So that is from 0 to 1. So if we plug 1 in there, we're going to get 1/3 minus 1 over 42 minus 0 minus 0. We plug 0 in there. Now, we're not really, the only reason I included that was because that's going to give us our error. So now if we get a common denominator here, that's going to be 14. So that would be 14 over 42, which is going to be 13 over 42, which is 0.30952 ... So we're supposed to round off to the thousandths place. So that 5 would round that up to a 0, which would round up to a 1. So that's that. Now the maximum error is going to be what we get from this last term here. So plugging in 1 there is going to be 1 over 1320. Alright, it's about that time. Last notes of Chapter 8. We got a few left in Chapter 9, and that will do it for this year. Have a good day, everybody.